Guys, we are back with a good one. We are back with a good one. I just went on this crazy run. Just quick tangential before we hop into the material. Little fun talking point before we learn about polymorphism. Guys, I went on a run this morning. We got the 6 a.m. run club. You know, I was over there at freaking 5:45 leaving the apartment, and my legs are toast. You know, these guys are the real deal. One of them's training for like 100-mile run. I'm kind of new to it, you know, and they're out here running like freaking animals. You know, they were cooking. We did a 5-mile run. They ran 7-minute 20 pace for 5 miles. Yeah. So I'm not gonna lie. I ran so much my knees are sweating. Anyway, let's talk about polymorphism while my legs slowly break down. But let's dive in. So what did we learn the last episode was, or the last few episodes, right? Is this idea of abstraction and inheritance and encapsulation. I mean, classes as a whole, right? So classes as a whole, we have a few of these techniques we're using, right? Let me sneeze real quick. Ooh. So with abstraction, we learned, classes are these like data models that we can constantly build. Like, let's say we have a human class, we could build the human class, or this one we have a rectangle class. We can constantly easily use that class to build rectangles very quickly, at least from a data standpoint. Now we have these other techniques of encapsulation where we can tuck methods inside, and the rectangle class might do a whole bunch of fancy dancy stuff that Azure doesn't need to know, or other developers or your future self doesn't even need to remember. We have ideas like abstraction, where you can kind of build, classes on top of classes. So maybe a square is a rectangle, but a rectangle is not a square. So you could build a square on top of the rectangle class, or basically build a more parent class and then build a child class on top of that. Or that's inheritance, rather. The kind of abstraction, abstraction and inheritance gets a little bit blurry for me. So abstraction is one of the key concepts in object-oriented programming to handle complexity by hiding unnecessary details. So abstraction a little bit similar to encapsulation. Just here's the differences again. We covered that, but I guess for the short token of it, let's read it. So abstraction is a technique that helps us identify what information and behavior should be encapsulated and what should be exposed. Encapsulation is the process of doing that. Okay, so really inheritance was building that parent contract to child contracts and a parent class to the child class, and then finally we're going to use polymorphism. So basically, but as a whole, this last couple bits, it's been focusing on classes as a whole. That's what we're doing. We're just ironing out the classes of what they are as a whole. So let's dive into polymorphism. While inheritance is the most unique trait that object-oriented languages claim to have, polymorphism is probably the most powerful. But a little bit dicey on it, because they said that about the last one. The last one was the most powerful. Now this one's the most powerful. They're good sales, but I'm on to them. I'm teasing. Okay, so polymorphism is the ability of a variable, function, or object to make or to take on multiple forms. So, for example, in a programming language that supports inheritance, classes in the same hierarchical tree may have methods with the same name but different behaviors. So here we have over here we have creature, dragon, and kraken. So it looks like they all move, or they all have the move functionality, and the kraken swims, the dragon flies, and the creature moves. So in this example, the child classes dragon, kraken are overriding the behavior of the parent's class. Oh, see, they're taking in the creature class and they're overriding. They're still using move as a class, but they're overriding the content of it. So okay, so that's a little bit of polymorphism here. So the assignment, first we'll need to add a new class to or add a class that represents rectangle. Take a look at the test cases in main.testpy to see how it's expected to behave. So here's some behavioral cases. We have a rectangle here where we could pass in some corners, or it seems to be some coordinates, and that coordinate seems to be a bottom left coordinate and then top right coordinate, I imagine. Okay, so variables should be passed into the constructor in this order: x1, y1, x2, y2. So what did we need to do? First, they just want us to build it. I'm a little bit confused on exactly what they want us to do. Okay, so rectangle x1. So do we just want to return a tuple of chord 1, right? Which equals x1 and y1, and then we have chord 2, which equals x2 and y2. Let's see. And then I will pass those in here as a tuple as well. And let's run it. See, should return none, not tuple. Okay, let's see what it wants. So air rectangle object has no attribute x1 fail. So do they want us to use it? Is that what I'm saying? Is that what it is? Rectangle? We can just say rect. Sorry guys, my brain is just getting into it. So let's see. We'll do that and that. So that'll be our coordinates. I'm not sure. I'm not sure. My phone is going off. Let me put that down. Let's see. So assignment first, we'll need a new class that represents rectangle. Take a look at the test cases in main.testpy to expect how it performs. Variables should be passed into the constructor in this order. So does it just want us to build the constructor of it? Is that what I'm seeing? Self.x1 equals x1. Sorry guys, my brain is just getting into it. You know what I mean? Just getting into it. So let's see if this will do what we need it to do. So submit, boom, there we go. Okay, so it was just initializing the classes. Fun, we got some more Cartesian planes. Here we go. Okay, so get edges. Remember that with normal units, we were checking if their XY point was within the rectangle of a dragon's breath to see if they were hit by fire. With a dragon, because they're so big, we're going to need to check if the dragon's body, a rectangle, I love how I just air quoted a rectangle. It is a rectangle, but a rectangle. A conspiracy against rectangles now. Is within the fire. Also, a rectangle still, the image below, contains an example of a fire breathing hitting a dragon or a fire breath hitting a dragon. Okay, so these two dragons, that one can breathe fire, the other's getting hit. Or is this the dragon breathing fire and it hit itself? That's the questions I have now. Okay, so in this assignment, we'll be writing up the overlap method. If the coordinates have been made private members, first let's set up some helper functions, some helper methods. Write the following methods. So it looks like they've built them out for us. We get left x, get right x, all that stuff, or get top y, get bottom y. Remember that x1 or x2 could be the left x based on the value in the Cartesian plane. The same goes for the y value. So it sounds like we want to take the lowest value to be the x1 for the left, so out of x2. So we want to compare self.x1. If self.x1 is less than self.x2, return self.x1, and then we could say else return. I think this will just work though. We don't need to do an else statement. It simplicity means that, so we could say that here for this and just flip the sign there, and we can do the same thing for this just with y's. So the logic goes such, so get top y. I guess this one would be if y1. I don't know if this will actually work now that I'm thinking about it. Okay, so oh, there we go. I think that's why. Okay. So here's what I'm thinking now. It's because we take x1, and if the value is less than x2, so let's say x1 is 1 and x2 is 4, we say the leftmost x is x1. It's 1. It's the lower of the two. If it was the opposite, so if x1 was 4 and x2 was 4, we would say x1 is 4, which is not less than 1, or return 4. Or return 1, excuse me. Got it backwards there. So is this one backwards as well? Does it need to? If x1 is 4, so the x1 is more than x2, so if x2 is 1, so we say if that's 4, and that's 1, then return 4, right? Yeah. Okay, I think we're dialed. I think that'll work. I think that'll work great. And then if self.y1 is greater than self.y2, return y1. But this is where it kind of hurts a little bit, because why would it matter which one's y1 or y2? Just the most valuable one, right? We'll roll with it. We'll roll with it. Okay, so let's see. Oh, look at that. Doing all that thinking and talking. Had it right the whole time. Okay, so check if rectangles overlap. Let's write the overlaps method. It should check if the rectangles overlap a given rectangle or rect. Return true or false if the rectangle overlaps with any part of rect, including just touching the sides. So it's an inclusive thing. Here are 4 conditions that must be true if the rectangle A overlaps and touches rect B. A's left side is on or to the left of B's right side. Okay, yeah, that makes sense. Let's just write it. Let's just write the thing, So I think we have all of these. I think we have access to all of this. all the self still. And I think we're checking it against x1, right? Or against this rectangle's x1. Let's see if we have some of these members. They might be private, so we may not be able to fully access them, but let's see. So looks like we're given here, let's say this is our rectangle, boom, here. So we have 5, 5, 8, 8. Okay, so these I think are the coordinates, right, for the rectangle. So if this is on the Cartesian plane at 0, 0, and then we go across 4, up 4, that would be our box, right? Boom. That's how I'm reading it, right? And we need to check if self rectangle overlaps with that 4, 4, 4, and 0, 0 box, right? Which it would not, because it starts at 5, 5, and 8, 8. So I don't think it would overlap, but we now need to programmatically attack this. So I don't want to read their definitions of A's left side is on or on to the left of B's right side. What I kind of want to do is just think about it programmatically first and draw the two rectangles in my brain. So we have 0, 0, 4, 4, and then we have 5, 5, and 8, 8 over here, and we could just check if there's any overlap, right? So I think what I can do potentially is take the coordinate here and take the coordinate here and see where they're at in comparison to each other. Then we have to take the coordinate here and the coordinate here as well. But the tricky part is we're also dealing with the negatives. So pretend the test case, if this was 5, 5 and -8, -8, these two would actually touch. So we have to programmatically tackle that as well. So let's think about it. So I do like the idea of distilling it down though to two coordinates rather than maybe we'll end up checking each side. But in my brain it makes more sense to say, here's the coordinate on 0, 0. Where is that in relation to 5, 5? And I guess the other thing is, where's the second coordinate? So we're building the first rectangle, which is 0, 0 to 4, 4. So then we now need to check where's the first other coordinate? Are we anywhere in sight of the first other coordinate? I kind of like that approach a little bit, but I'm trying to think how to do it. So we take the first coordinate. We would have to basically build this first rectangle and then check, and we'd have to build the second rectangle, I guess, to some degree, and see if they overlap. So we kind of are doing the long work here anyways. But I like the idea of tackling it of a coordinate, adding the other coordinate values, the x values maybe. So we take x1 plus x2, so that would be 4, and then we just check that against R2's x1, rectangle 2's x1, which is 5, right? So we can at least just initially say, hey, are we within vicinity of that one at all? So let's look at the test cases though, because I want to see how they do this. So rectangle, boom, boom, boom. Okay, let's see. Great. Okay, so this is the one we're looking at, or this one right here. No. Which one is it? It's 0, 0, 0, 0, 4, 4, and then 5, 5, 8, 8. Okay, so we're looking at this test case right here. Okay, so let's see. So I think we're gonna have access to all these. Let's just double check real quick. This, and I guess I could just do a little checksum method, right? Just check one of them, and then vicariously, if we get one of these points, I'm sure we'll get the rest of them, which we do. Okay, so we do get x1. I do like that approach. So if we take x1, absolute value of x2, and check in all directions, where's the other rectangle, right? Where's the other coordinates? I think it's a decent idea. Right? So let me print the rectangle again, right? And let's think about it. So here is that rectangle. So we have absolute value of x1 plus x4, so it's 4. And we would just check, hey, where is the x1 on the next one? Where's the x1 on the next one, right? Which would be at 5. So immediately we're like, well, is it what's the next test case we could do, right? But that gives us at least a little breadcrumb in the right direction. Now I'm trying to think on the negative side if this would work too. So let's flip it real quick. Let's say you have to check both directions, right? So just to handle it, let's see. This one's going to hurt my brain, I think. So okay, so self.x1 plus self.x2, right? Is that what I'm seeing here? So 0 plus 4, so that's 4. So we're going to say distance to check, boom. Okay, so that's going to be the absolute value of this, because if it was 0 and -4, or let's say if it was 1 and -4, we would check 3 apart, but we need the absolute value. We need the total length to check. So it's absolute value of that. Maybe I actually want to do ABS of this, boom, and ABS of that. So absolute values. And basically, I think in respect to this, we want to check where rectangle 2 is. So where is rectangle, this bit right here? How do we get that value? So do I say rectangle 3? No. Here, boom. Okay, but we don't want that value. We actually want, oh no, that's fine actually. So here's an example, right? So this would be rectangle 1x. So to differentiate from the self.x1, we have rectangle 1x. So if, let's see, so let me be in scope of this. So if distance to check, or if rectangle x1 is less than distance to check, oh, but that only works at a, guys, yeah, my brain is just not with it right now. This is only like the third problem too. We got so much more. Okay, so we're gonna check out the solution to see what they got. Okay, overlap self.get left. Oh my god, we already built all these functions. Oh my gosh. Oh my gosh. Oh my gosh. You gotta love it. You gotta love it. You gotta love it. Sorry, guys. I feel dazed and confused right now. Dazed and confused. But it's still an important day to get things done. Okay, so let's just maybe go back real quick, absorb a little bit of that. So self.get left x. Okay, boom. So we're checking that and the right values against, oh, I see, the self.get left, self.get right. So we really should have actually read this the whole time. They were leading us proper. Golly, that was my fault. That was my fault. Okay, so bringing it together in the Dragon class. Let's bring all that we've done together in the Dragon class. The Dragon class should override the units class in area method. Instead of checking the center position of the dragon is in the given area, we'll check if its big dragon body overlaps with the given area. Assignment. First, complete the dragon's constructor. Okay, so we do need a member of hitbox, it looks like. So self.hitbox, which is, the hitbox is a rectangle object, so it's going to be rectangle. It's like you've been provided with the height, width, and center position for the x and y. Okay, so we have our center position of x and y. So the height would then be, let's run it by. So if the height is 2, our center position is 2. We need to give this rectangle all the coordinates, right? All the x1, y1, x2, y2. If we're given the position 2, the height is 2, I can divide the height in half. That's what we need to do. So the coordinate is going to be height divided by or height divided, the first coordinate is going to be height divided by 2 subtracted by, or you know what, I think I have it backwards. So position x subtracted by height divided by 2. I think that's going to be our first coordinate. And then our, technically this should actually be width. And then this position y is going to be this one. So we would just do the opposite. So we need we start with this. The width is 4. So we have 4 divided by 2, which is 2. So we take position x, which is 2, minus 2. So 1, 2. So that gets us on this plane. And then position y for that first coordinate, we have height, which is 2. 2 divided by 2 is 1. So we have position y, 1 minus 1, which is 0. Not, oh, which would be, oh, that would work. Okay, great. Oh, you just got to love it. You just got to love it. And then the opposite would be, or the next 2 coordinates would just be plus. So that would be the rectangle here, I believe. Self-hitbox rectangle. It's not loving it, though. It's not loving it. Oh, and then I see we need to return. Let's see. So first, complete the dragon's constructor. The dragon needs one more private member, the hitbox. The hitbox is a rectangle, boom, 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 boom. And then we need to do the in area. So next, you'll need to do the in area, which is self.hitbox overlaps with the thing. So I think we have an overlaps method, right? Don't we? We got to do more overlaps. This is killing me already, folks. Next, you'll need to override the in area method, create a new rectangle object with the given corner positions, and use the rectangle's overlaps method. Oh, here we go. We're back at it. We're back at it. Here we are. So self.hitbox. Let's see. Self._hitbox.overlaps with these. Is that what we need? Vaguely. Or is it this, right? Do we say rectangle, right? overlaps with self.hitbox, right? Is that what it is? And then we return that. Ooh, baby. Ooh, baby. Ooh, baby. Okay, we're cooking with a little grease in the skillet. You know, we're getting her moving now. We're getting her moving now, folks. So poly means many, morph means forms. Let's go with it. Nice. Didn't even read the deal. Let's go. Let's go. So the main benefit of polymorphism is to write fewer lines of code in your class, is to hide the differences between subtypes from your users from code. Who wants to be a millionaire? Is it answer A, B, or C, or D? So to give your users of your code different function signatures for a single method. That sounds kind of about right. So to enclose the complexities of your classes behind data, behind getter methods. So that's kind of abstraction and encapsulation stuff. To write fewer lines of code is kind of what a class does. So to hide the difference between your subtypes from users and your code. I don't know, folks. So basically we want to affect methods is what I understand. So let's just send it on C, see how it goes. Wasn't the right answer. What, we lost $1 million, guys. It was a bad time. Don't do it. Okay, so morph means to change. Polymorphism programming is the ability to present the same interface for many different underlying forms, data types. So it's maybe to enclose the complexities of your data